So hi guys. So today I'm going to solve this problem. This is a pretty nice question. This is from Nbhm 2019. It is question number 19. It is saying that for R a positive real number. Okay, so basically they have defined f of R to be nothing but integral c of R sine z by dz. Okay, so yeah, where CR is the contour R e to the power I theta, right? Where theta runs from 0 to pi. Now they are asking for what is limit r tends to 0. Basically, like r gets smaller and smaller, closer towards 0. So what is limit r tends to 0? F of r by r. They are asking for that. Now let us look at the curve. Okay, so right, this is a semicircle. This is minus r. This is r. Since theta runs from 0 to pi. Okay, so this is 0 and this is pi. Okay, so basically in the question they are asking as limit r tends to 0 f of r by r. Now f of r, like CR will also change for r, let's say 1. This is so this is like the semicircle, right? I mean the so for r a bit smaller, this will be this like this. So as it tends to 0, r tends to 0, I mean so they're asking for limit r tends to 0 f of r by r. So basically concentric semicircles. Now, okay, so they are asking for, uh, so let me write it properly. We want limit r tends to 0 f of r by r. We want this, okay? So yeah, now, uh, now how to approach this? So let me draw the diagram again. So let's say this is our diagram. This is our semicircle. This is minus r, okay, and this. So at first to find, okay. So so basically, like our main job is to find f of r, right? So that's what we want to like. I mean, f of r is nothing but integral c of r sine z by z. Okay, okay. Now, so yeah. Where was I? Yeah. So basically, now we can think like this. Like this is our CR or the curve R, right? Now, this goes like this, and this is, let's name it LR or line R, right? So, I mean, the gamma R is the whole closed contour, right? The whole, you go like this and this. So basically, we define gamma R to be CR plus LR, right? And we know, and one more thing, like there is a reason we did this because we know. Now, let us try to find this. Like, let's say gamma R, let's just say sine Z by Z dz. This is nothing but integral CR, okay, sine Z. Maybe I should have write FR, but that is okay. dz plus, okay, LR sine Z by Z dz. All right. Okay. So, yeah. Now, what is gamma R? I mean, what is the integral sine Z by Z mm, in this contour, right? In the closed contour. So in gamma R, so that will be 0 because like we know because the residue we need to find the residue at 0, right? And sine Z is nothing but Z minus Z cube by 3 factorial plus Z to the power 5 by 5 factorial and so on. So now sine Z by Z is nothing but 1 minus Z square by 3 factorial plus, yeah, something like that. Now we know that the residue is nothing but the coefficient of 1 by Z, right, which is 0. So integral, I mean, we can also use Cauchy's integral formula and so on. So uh yeah, so this or the directly the residue formula. So Z and Z will get cut and limit Z tends to 0, sine Z will be 0. Or we can also see that the coefficient of 1 by Z is 0 here. So this will be 0. Okay. So so gamma r is 0, right? S- s- So this is 0. Okay. So basically what do we have? We have is f of r plus, right. Okay. Okay, let me write it first. Okay, then I will. Hmm, let's say this is LR, uh, sin z by z dz equals to 0. Now our main goal is to find this, right? Uh, Now our main goal is to find this. This is minus r, sorry, minus r to r, and this part, I mean this is the line LR, right? So I mean this is on the real axis. So basically, like this, we will get reduced to minus r to r, okay, sin x by x d of x is 0. Okay, now basically f of r is nothing but minus r to r si- sin x by x dx. Now, what is our main goal? Our main goal is to find limit r tends to 0 f r by r. So we divide by r and take a limit. Take the limit on both sides. Okay. So like this. So we will have this. All right. So this will be limit r tends to 0. Okay. So let me take the minus outside. Okay. This will be sorry, minus r sin x by x dx by r, right? Now, as we can see, limit r tends to 0, this will be 0 by 0. Okay, so we will use the L'Hopital's rule, and for that, on the upper integral, we can use the Leibniz rule, okay, to differentiate under the integral sign. All right. So, yeah, so basically, this will imply limit r tends to 0, f of r by r to be minus. This will be sin r by r, and yeah, so this will be minus 2 sin r by r. I actually skipped a few steps, but we can differentiate using Leibniz rule. We will see that this will be sin r by r, dd r of r, which is 1, and minus sine of minus r by minus r. I mean, okay, this is an even function, so yeah. So, okay, so by and using L'Hopital's rule, this will be 1. I mean, differentiating r will be 1. Okay, so we will take the limit. Okay, so this will be minus limit r tends to 0 2 sine r by r, which is nothing but minus 2. So here is our answer, that limit r tends to 0 f of r by r is minus 2. So it's a pretty nice question. Okay, so this is answer is minus 2. Thank you guys. Thank you for watching.